This is a typical IB thermodynamics question. They give you some process like this. Notice that this is an isobaric compression, expansion, right? This is an isochoric cooling. And then this process here, they haven't identified yet, right? It suspiciously looks like an isothermal process, and here's why, right? Notice it starts at 5 and 2, and we can, put those numbers in and everything, right? But 5 times 2 is 10. And then if you go out here to 5, they sort of hide the 5, right? But 5 seems to be associated with 5 and 2, and that would also multiply to 10, okay? So they say that the temperature here is 400 kelvins, and they ask for the maximum temperature of the gas during the cycle. Well, the maximum temperature is going to be out here, right? We've got the same pressure, but we've got much more volume, right? So therefore, it has to be at a higher pressure. And from here, it cools. So that's got to be the maximum right there, okay? Now, if you look at B, right, our volume here is 2 times 10 to the minus third cubic meters, okay? Here, it's 8 times 10 to the minus third. The pressure stays constant, but you have 4 times the volume. And the only way to do that is to have 4 times the temperature. So the quick answer here is that the pressure at B, the temperature at B is 4 times 400, because it's 4 times the volume, right? Is 1600, and that's the right answer, okay? Now let's imagine that you really don't like that. Well, obviously you can do this. You can go PV over T equals PV over T, right? The pressure stays the same for this process, right? So you've got 5, you've got 2 times 10 to the minus third over 400 equals, what is that, 8 times 10 to the minus third over whatever that temperature is at B, right? Okay. And then, of course, when you cross multiply and do all that stuff, right, you'll end up with 8 times this divided by that, which is the same as multiplying that by 4, okay? Another way to do it, too, is you can actually use PV as nRT. If you love the ideal gas law, since at A, they tell you the temperature, you can find the moles, and then you can use the same equation to find the temperature anywhere. It's up to you. You don't have to do that. That seems like more work. This is what I do. I just say, since the volume is increased by a factor of 4 and the pressure doesn't drop, therefore the temperature has to increase by a factor of 4. And remember, that only works with kelvins. Any Celsius, you got to turn into kelvins.